All right, welcome back. We are going to be doing solving equations. So we're going to do number 10 right here. It says solve for x. And so when we're solving for x, our goal is to get x by himself. So essentially, you're going to use each of these numbers and you're going to get rid of each of them one at a time. Okay. And so the very first thing that I notice is that I have a y. And some of my students get all freaked out about, oh, there's a y, but it doesn't matter. Okay, I'm going to pretend that this says like, I don't know, 24. Okay, and I'm going to treat this as one number. So the very first thing that I do is I'm going to decide if I want to distribute this out or if I want to use the inverse to get rid of the 3/4. Okay, and it doesn't matter which way you do because you will still, as long as you do the steps correctly, you will still get the same answer. So let's see. I think most of you like to distribute. So I'm just going to show you a different way and see if you like it better. Okay, so the very first thing I'm going to do is just copy it correctly. If you know Miss Johnson, she tends to copy things and she messes up. So I'm going to take the second to make sure I copied it correctly. 3/4 parentheses x minus 2y equals 12. Okay, so again, I could distribute this, but I'm not going to. I'm going to so this is being multiplied. So I'm going to actually undo multiplication. And you all know, like, how do I get rid of multiplication? Then I would divide. But then if I'm dividing by a fraction, you all would be like, oh, no. You'd multiply by the reciprocal. And so when I multiply by the reciprocal, you should see what happens right here. So you should see what happens right here, right? So some of you see this as, oh, that's 3 divided by 3. That's just a 1. And 4 divided by 4 is just a 1. So now I have 1. This is just one big one, and I can just draw a gigantic one. You guys all make fun of me how I draw my gigantic one, right? So this is a giant 1, so it's 1 times something. And a long time ago, that was probably one of your favorite multiplication tables because 1 times something is that same something. So this part now is just a 1, which I'm not going to write them anymore. And so now I have x minus 2y equals to whatever this is. Now, a lot of people do this differently. I like to make my numbers smaller. So I see 12 and 3 share a factor of 3. So I'm going to divide out by 3. There's 4 3s in 12, and there's 1 3 in 3. So 4 times 4 is 16 divided by 1. Oh, that's 16. So take a second to make sure that you're all with me. Pause the video, go look at why would she multiply by the reciprocal? Oh, that's right, because she divided by 3/4. And when we divide by a fraction, we're really just multiplying by the reciprocal, right? How did she do this again? Oh, yeah, that's right. She factored out 3. How many 3s in 12? Oh, there's 4. How many 3s in 3? Oh, there's 1. So there goes my equation. So again, if you are kind of like tracking with me, my goal all the way down here is to have x by itself, right? All the way down here. Maybe I'll even put it x equals. So if my goal is to get x equals, then I like this pink equation or red, I don't know, fuchsia equation way better than this black one because look, I have less numbers. So certainly I am on my way there. So when you're doing math, you want to check yourself and say like, hey, did I do it? Did I take a step in the right direction? Right. Okay. So the next thing is like, hey, how do I get rid of this guy? Now, some of you want to like do all kinds of things, but remember, I told you to view this as one number, right? Like 24. So how would you get rid of minus 24? How would you undo? How would you inverse minus 24? And you guys say, oh, the inverse of subtraction is adding, or the undoing of subtraction is adding. And I'd say, very good. What would you add? What would you add? And whatever you do to one side, you have to do the other. So what would you add? And someone says that thing. Exactly. I would add 2y as well. So 2y, 2y. So then my answer is x equals 2, right? Because this is a 0. 2y plus 2, negative 2y plus 2y is 0. That's just a 0 right there. So then I get x is equal to whatever this is. Now, some people want to add these things together and give me like 18y. That's not correct. So I'm literally going to write 2y plus 16. Some of you want to write 16 plus 2y. That's fine too. Math tends to put the variables in front. So I'm going to put my variables in front. The reason why 2y plus 16 doesn't equal to 18 is because, can you pretend that y is like a $5 bill? And it says $16 plus 2 fives. Does that equal to $18? No, right? It does not.
One has a variable and the other one doesn't.
Exactly.
Which means we can't.
Exactly. Very good. Thanks for explaining that. Exactly. So we say that these are not like terms, and so we just leave it like that, which you all are like, so that's actually easier than if that was a number. Yeah, actually, because you just put them next to each other, right? 2y plus 16. So this is my answer. I'm going to put it in a little box. If you're trying to get an A on this quiz, because we call this the redemption chapter, right? I will say this over and over again. Then you will check your answers. All that means is I'm going to take this section here and replace it right there. Okay, so I'm actually gonna check my answer because I want you to come into the practice of that. So 3/4, and I'm gonna leave a big like space right there, and then I'm gonna put minus 2y, and then equals to 12. And then what I'm gonna do is I'm literally gonna copy and paste this, not because I'm lazy, but because I literally want you to see this as like, I want you to see that I'm just taking this and putting it here. Like you are watching me. Where is that? Where did you get that from, Miss Shaw? Oh, that's my X. Why did you put it there? Because that's where X goes, right? Okay. So then I'm going to just simplify and see what happens. Does anybody see anything that happens on this side? Anything at all? What do you see? What do you see happening here?
The y. So the two y and a negative or minus 2y cancel out each other, and then you're left with a 16.
Very good.
And then it would be we would have to divide the fraction.
Wait, hold on. Let me catch up to you. So you're saying 3/4, and then 2y minus 2y equals to 0. Is that what you just said? 2y minus 2y equals to 0, right? So all I'm left with is that 16. Oh, that makes sense, right? And then in my head, I'm like, 3/4 of 16. What the heck is that? And you can divide out your factors. Very good. You can divide out your factors, right? So 16 and 4 share a common factor of what? Ouch. Of 4?
16 and 4, you can do 4 times 4 equals 16, which means it would be easy to divide.
By 4, right? How many 4s go into 16?
4.
Good. So that goes on the top. And how many 4s go into 4?
1.
Yeah. So that goes on the bottom. So what's 3 times 4? I'm hoping you say 12. If you say 12, I'm excited because that means my answer is correct. Is 3 times 4 12?
Yes, it is.
Yay. So I'm very happy, very excited. Again, this is called the chapter of redemption for a very specific reason. I have access to check every single question, right? So boom, I'm really confident in this. Let's see. Are you comfortable with saying why you did something, right? Why did you multiply by 4/3 to find the inverse of multiplying by 3/4? Why did we add 2y here? Why did we add 2y here? To inverse minus 2y, right? So that is how you solve an equation. Solving an equation, if you see what you are doing, then you will be able to undo it. That's the whole goal. I want to undo it, right? All right. Thank you for listening. Oh, it's right here.